All right, guys, here we go. Review for test 27. Let's knock it out. Number 1 says 4 to the x is 25. You cannot find the same base on that one. So what I'm going to do, what I'm going to do is just do log both sides. Remember, your exponent goes in the front, so I'm going to say x log 4 equals log 25. And just divide both sides by log 4. And just punch that right straight into your calculator. Punching in log 25 divided by log 4. And I'm getting 2.3219. We'll go 4 decimal places tomorrow. Number 2 just has one log. Anytime you see one log, remember we do the base to that power equals that. So I'm going to go 5 to the third power equals x, which means x is 125. That's all there is to it. Number 3 the same thing as number 2, except as a natural log. Remember, natural log is base e. So I'm going to go e to that power is x. I'm going e to the negative 5 equals x. Just take that and punch it in your calculator. It's second e, negative 5 power, getting 0.0067 on that one. Number 4, I have 2 logs that are subtracted. Remember, you can never subtract logs. So I'm going to divide the 2 numbers. I'm going to do the x over the x plus 3, and that equals negative 1. Now, there's no base written there, which tells me the base is 10. And because there's one log now, I'm going to do that base to that power equals that. So I'm going to do x to the x plus over x plus 3 is really 10 to the negative 1. And don't forget, the negative 1 flips that 10, makes it 1/10. And then we're just going to cross multiply. So I'm going to go 10 times x, and I'm going to do 1 times x plus 3, and just move the x over, gives me 9x equals 3, divide by 9, gives me 3/9, which is really just 1/3. Check your answer. I forgot to say that. Make sure you check your answer back up here just to make sure it doesn't make a log negative. Remember, no negative logs. Number 5, again, it has subtraction in it. So remember, that means division. So I'm going to say log base 3, x plus 8 divided by x plus 1 equals log base 3, 6. And because you have log both sides, one log on each side, you can just cancel out those logs. And I get x plus 8 over x plus 1 equals really 6, or 6 over 1. So I'm going to cross multiply again. Going this way, 6x plus 6. 1 times x plus 8 is just x plus 8. Let's move that x over. Get 5x plus 6 is 8. Move the 6. Divide by 5, 2/5. Now, before I circle that, plug it in. That's good. That's good. It's just got to keep the logs positive. That's what you're checking for. And number 6. Number 6 has, this is a third subtraction in a row. Just in case your test has addition on it, you actually multiply. But this is a third subtraction. So I'm going to do x over x minus 4 equals natural log 3. And again, down to one log on each side, you can just cancel the logs. Gives me x over x minus 4. Again, 3 is really 3 over 1. Let's cross multiply. That's x. Cross multiply this way. That's 3x minus 12. Move that 3x over and divide by 2. I get x is 6. I'm turning up here real quick. Looks good. X is 6. And number 7, there's some addition. 2 times. So number 7, 2 logs added together means I'm going to multiply. And if I do x times x plus 1, I get x squared plus x. Over here, if I do 2 times x plus 3, I get 2x plus 6. Because there's one log on each side, again, cancel the logs. Gives me x squared plus x is 2x plus 6. Because there's an x squared, I'm moving everything over, so I can factor. If I move the 2x over, it's negative 1x. If I move the 6 over, it's minus 6. Now let's factor what I've got. I got x minus 3, x plus 2, which gives me these 2 answers, positive 3 and negative 2. Now, negative 2 makes that log right there and that log all negative. So negative 2 is out. The 3 looks good. So the only answer is 3. And one more, number 8. Number 8 goes back to what we were doing on the last slide. You only have one log. You do the base to that power equals that. So I'm going to do 8 minus 7x equals 2 to the third. Now, the weird thing about 2 to the third is it is 8. So if I move that 8 over, I get negative 7x equals 0. Divide by negative 7. Still got 0. Plug in 0 first. It works perfectly. There you go. Number 9, population growth of Mexico. Okay. It says in 2011, the population of Mexico was about 113.7 million. Exponential growth rate was 1.1% per year. Find the exponential growth function. Okay, the function, remember, is going to look like P of t equals the original amount, which in this case is 113.7 million, e to the kt power, and K is your growth rate. So this time it's 1.1%, change it to a decimal 0.001, and T, so for time. You need to leave a T in there because we put P of T right there. So that's the function. So when it says 2016, 2016 is 5 years after 2011. So what I'm going to do, basically doing P of 5. I'm going to put a 5 in for the time for 5 years. So I'm going 0.011 times 5. I'm going to punch that in and see what I get. I'm getting 120.1 million. Okay, no big deal there. Number 10, suppose that 3,000 invested in interest rate K, compounded continuously. Okay, what is the interest rate? First of all, if it's compounded continuously, that means it's PERT. So I'm doing A equals P e to the RT. Part A is asking me for the interest rate. It says they're invested 3,000, that's the P. It grows at 3,600 in 5 years. So I have 3,600 equals 3,000. E, rate I don't know, but time it took 5 years. Now remember, the answer to a log is the exponent, so I got to find that exponent on the E. So first step's divide by 3,000, so I'm dividing 3,600 divided by 3,000. Getting 1.2, so that's 1.2 equals E to the 5R. Remember how to get rid of an E. We're going to do natural log of each side, and the exponent remember goes in the front. So all I'm going to have left on the right-hand side is 5R equals natural log of 1.2. So I'm going to take my calculator and punch in natural log 1.2 divided by 5. And I'm getting this from my rate. I'm getting 0.036. There's my rate. Find the exponential growth function. So for part B, just find the function. A equals what we started with, 3,000 e to the 0.036t. That's the function because I can plug in anything in for t I want to and get, what it is. So like part C, for example, says, how much will it be worth after 8 years? I'm just going to take that 8 and plug it into that t. So I'm going 3,000, if I can do it right, 3,000 times e to the 8 times 0.036 power. I'm getting $4,001.27. And then the last question, how long will the 300, should we say 3,000, have doubled? Not that it matters. So if it doubles, it means it ends up being 6,000. It started at 3,000 e to the 0.036t. I'm looking for t. How long did it take? So divide by 3,000. That's 2 e to this power. And again, I'm looking for the exponent. I need the e to go away, so I'm going to do natural log of each side, which gives me just 0.036t over here. So to finish up my problem, the last answer for D, I'm going to do natural log 2 divided by 0.036. And by the way, that's how you find out how long it takes anything to double is by doing that. It's going to take 19.2 years. Quite a while. All right, hope that was good. Number 11. Let's see here. Okay, number 11, solve by graphing. So what you need to do on this one is you need to get y by itself so you can punch it in your calculator. So that first equation, if I move the 1 over, I'm getting 2x minus 1. This one, if I move the 1 over, I'm getting 2x plus 1. Now, one thing I know already is those two slopes are the same. And remember, if slopes are the same, that means they're parallel. So I'm going to punch in my calculator, but I'm doing that right now. And what I'm seeing when I punch it in are two parallel lines. Remember, the answer to a system on a graph is where do they cross. We will remember where they intersect. We will go second calc 5, enter. So look at your calculator right now. Hit second calc, and look at what number 5 says. It says intersect. Then you could just hit enter 3 times, and it will tell you exactly what it is. This time is no solution because they don't intersect at all. Okay, I would expect them to have a solution tomorrow. All right, number 12 says substitution. You must show work. One good thing about number 12 is I already know what x is. X is that right there. So I'm going to take that negative 3y plus 3 and plug it in for the other x. So I'm going to say negative 3y plus 3 plus the 4y equals 6. If you add all that up, you get 1y plus 3 is 6. Move the 3 over, you get 3. There's the y. Y is 3. Now, once you get that, the good thing about substitution is you can plug it right back where you started to get your x. I'm going to plug that 3 right there for that y. So I'm going negative 3 times 3 plus 3, which is negative 9 plus 3, which is negative 6. So my solution is negative 6, 3, and I showed no work. That's all you got to do. 13. 13 says solve by elimination, so also must show work. So I need to make either eliminate either the x's or the y's in this one. I think the x's look easier because I can just multiply the top equation right here just by negative 6, which will give me negative 6x plus 18y and that equal to negative 12. And I can just bring this equation straight over. 6x plus 5y is negative 34. I'm just going to add those together. The x's are gone. That gives me 23y over here. The right-hand side is negative 46. Just divide by 23. I get negative 2. Okay, there's my y. Now I need to take that y and plug it in either one of the two equations. The top equation, the number's a little smaller, so I'm going to go there. So I'm going to do x minus 3 times negative 2 equals 2. That's really a positive 6. Move that 6 over, I get negative 4. So my solution, using elimination and showing work, is negative 4, negative 2. All right, 14, let's find some zeros. When I'm finding zeros here, I'm going to start by making a list, the factors of 27 over the factors of 2. The factors of 27 are 1, 3, 9, and 27. So that's putting them over 1. 1 over 1, 3 over 1, 9 over 1, 27 over 1. Now I'm going to put them over 2. Oops. 1 over 2, 3 over 2, 9 over 2, and 27 over 2. That's my list. Now I'm going to take my calculator. I'm going to go to y equals. I'm going to graph that function and see which one of these is an x-intercept, or maybe 3 of them. Okay, so my graph crosses at in between negative 1 and negative 2. And the only one of these numbers between negative 1 and negative 2 is the negative 3 halves right here. So I'm going to take negative 3 halves, put it in my box. I'm going to go do synthetic, and I got to prove that I really do get a 0 there. So I bring down the 2, multiply, that's gone. Multiply, add, multiply, that's gone. So it leaves me with this right here. Now I got to find all the zeros. So one of the zeros is negative 3 halves. I got to find 2 more because my exponent's 3, my degree is 3. So I have 2x squared plus 18 is what I have left. I'm going to move the 18 to the other side, divide by 2, take the square root, which is going to be this, by the way. If I take the square root, put plus or minus, I got to take an I out because it's negative, and square root of 9 is 3. And then don't forget the negative 3 halves also. So there's the 3 zeros right there. And the last one. All right, so what we're going to do is we're going to factor this thing. We're going to say x plus 2, x minus 1. And that's really all you can do. This is where we make a sign graph. Because it's an inequality and because it's quadratic, we're going to make a sign graph. I'm going to say, put the zeros in there, negative 2 and positive 1. And you know what I'm going to do? What number I'm plugging in? You guessed it, it's 100. So if I plug in 100, that's positive, and a positive times a positive is a positive, which means it's going to go plus minus plus. My sign in the problem is greater than, which means what kind of numbers are greater than 0? Positives are. So I'm looking for my plus signs, which are from negative infinity to negative 2 with the parentheses, and also from 1 to infinity with the parentheses, because there's no equal sign up there. And there you have it. All right. Hope that helps. Hope you make 100 tomorrow. Do great on the few tests left. I can't believe it's almost over. See you tomorrow.